Hello, this is Captain Chaudhari. Today I'm going to do a typical numerical on list. In our day-to-day working on the ship, sometimes we want to find out how to correct the list, how much to put in a particular tank to correct the list, or sometimes we want to trace how this list has come. We want to find out what is the cause of the list. Well, I'm going to do a typical numerical whereby we are going to do some loading, some discharging and some shifting. So I've taken a numerical from my own book, that is Ship Stability. Let's say there is a ship of displacement 18,400 tons, km 11.2, kg 9.8 meters. She is listed 1.5 degrees to starboard. She discharges 310 tons of cargo at kg 8.2 meters, and the position of discharge is 5 meters to the starboard of centerline. She adds 200 tons each to number 3 double bottom, center and port. The port double bottom is 8.2 meters to the port of centerline, and both the double bottoms, they are at the kg of 0.7 meters. 75 tons of heavy oil is shifted from 5 double bottom, port double bottom to the settling tank, which is 8 meters above and 7 meters to the starboard. So to do these kind of questions, there is a typical format of table that we use, and so to do these kind of questions, we have a typical format, like the columns are weights in ton, kg in meters, vertical moments, that is the product of first and second column. Then the reference position with respect to the center line, or the amount of transverse shift that will be indicated here. This column may be omitted actually. You have port listing moment and starboard listing moment. I told you in my previous lecture that whenever we see a ship listed, the first thing that you should do is find out the initial listing moment, and whether you have initial listing moment to find out, or finally there is list. The final, initial or residual listing moment, the same formula, that is listing moment is equal to displacement into gm tan theta, will be used. So using this formula, let us find out what is the initial listing moment. So what is the gm? Km is 11.2 and kg is 9.8, so gm will be 1.4 meters. So displacement, initial displacement is 18,400 into gm 1.4 into tan of 1.5 degree gives me 674.5. So initial listing moment is starboard listing moment, that is 674.5 tons meter. So we start now. The displacement of the ship 18,400 tons, kg is 11.2, sorry, kg is 9.8 meters, and there is no port listing moment. There is a initial starboard listing moment of 674.5 tons. I put plus here, and over here the moments are going to be plus. Now when we discharge 310 tons, I put a minus sign here, and this is from a kg of 8.2 meters. We'll have a negative sign here also. Now this particular parcel of 310 tons is 5 meters to the starboard of the center line, and because it is discharged from the starboard, it's going to cause port listing moment, and that's going to be 5 multiplied by 310, that is 1550 tons meter, right? Next, there is loading of 200 tons over here. Also over here there are two double bottom tanks. One is on the center line and their kgs are 0.7 meters each. So it's going to cause a vertical moment of 140 each. Now the tank which is out of these two tanks, one of the tanks is on the port side and the port dB is 8.2 meters to the port of the center line. 8.2 meters to the port of center line. So it is going to cause a port listing moment equal to 1640 tons meter, right? The double bottom which is on the center line is not going to cause any listing moment, right? Only the vertical moments. Now there is a shift, and because there is a shift, there is no addition or subtraction of this weight. So over here I put 0 just to play safe, and this is 75 tons. It is shifted vertically upwards. Now 75 tons is shifted vertically upwards by 8 meters. Although I put 0 here, but the distance of that weight is increased with respect to the keel. That means the vertical moment which is taken from the keel would add up. So I will have a plus sign here. So there is an addition of vertical moment by 600 tons meter over here. Now while I shift from the double bottom to the settling tank, I am also shifting this weight starboard wise by 7 meters. The reference distance is 7 meters. Between the two tanks, the center of gravities are separated by 7 meters, which means that it is going to cause a starboard listing moment equal to 525, right? So let us do the other calculations. First of all, 18,400 multiplied by 9.8 gives me 180,320. 180,320. And then 310 multiplied by 8.2 gives me 2542. 2542. Now let us do the total of vertical moments. It is 180,320 minus 2542 plus 280 plus 600 gives me 178,658. 178,658. The total of weights, it is 400 minus 310, that is plus 90, 75 is not to be counted, so it is 18490. 178,658 divided by 18490 gives me 9.662. 9.662. And we know the km 11.2 is not going to change for small changes. We assume that 11.2 is not changing, so minus 11.2 gives me 1.537. 1.537 is the GM. Km minus kg is GM. Let's look at the port listing moment. It is 093190 and this side is 0.5. 1199.5. 1199.5. 1199.5 minus 3190. Oh, it should have been the other way around, but 1990.5 is the port listing moment. And to find out the final list, we use the same formula. So listing moment 1990.5. The list is given by tan theta equal to listing moment. Tan theta is equal to listing moment divided by delta GM. So we have 1990.5 divided by 18490 into GM, that is 1.537. So this is tan theta. So let's look at 199.0.5 divided by 184.90 divided by 1.537. Shift tan gives me list equal to 4 degrees. So list is going to be 4 degrees to port. In this question we did not allow for free surface effect, but in case there was some free surface effect, we would have said free surface correction is equal to resultant free surface moment divided by displacement, and free surface correction would have been subtracted from, we would have subtracted free surface correction from GM solid, and we would have applied GM fluid over here.